Okay, so this is the example we did in class. We're looking for the tension in the three cables A, B, and C. Starting with cable A, since it's in equilibrium, the sum of the forces on it will be equal to 0. So we want to find the forces that are on the 150 Newton block. And obviously, there's the force of gravity, and then the tension force. And so, again, because it's in equilibrium, the sum of the forces is equal to 0. So if we take the up direction to be positive, then the tension in the string minus the force due to gravity should be equal to 0. This just implies that the two are equal to each other. The tension has to be equal to the force due to gravity. So now we're going to want to find the tension in B and C. So we can draw the tension in those cables to be pulling upwards in this direction and upwards in that direction. And then the force of gravity on the 72 Newton block will be pulling downwards. And that'll include the extra 150 that's added to it or attached to it. So TB and TC point in opposite directions, and then the force of gravity points down. So now we want to find the tension in B and C. So we're going to take the right direction to be positive, X, and the up direction to be positive, Y. So we can then draw the sum of the forces in the X direction to be TCX, points to the right, and T minus TBX, which points to the left, and that's equal to 0. To find those components, we just substitute the angles. And so here you can see, when we're drawn in the picture, TCX will point to the right, TBX will point to the left. And remember, by geometry, this 60-degree angle here is the same as this 60-degree angle here. And so to find those components, the X component just comes from the cosine of the angle, the Y component just comes from the sine of the angle. So knowing that the cosine of 60 degrees is equal to 0.5, the sine of 60 degrees is equal to 0.866, we'll just replace sine and cosine in the equations with these decimals. Now to get the second equation, we have to write things in terms of the Y dimension. So in terms of the Y dimension, the two Y components of the tension are both pulling upwards, and so they're both going to be positive. And the weight, or the force of gravity, is pulling downward, so it's negative. And because it's in equilibrium, there's no acceleration, so it has to be equal to 0. We can then again replace the Y components using sine and cosine, or just sine in this case. And we know that the force of gravity, when you add up 72 and 150, is 222 newtons. When we plug in those decimal values, when you plug in those decimal values, you get another equation in terms of the Y dimension. Now, to solve for TC and TB, all you need to do is solve the system of equations that you've set up. We've got one for the X dimension, one for the Y dimension. We can then combine them and use elimination. So here we just have the system of equations. We're going to solve it using elimination. So we're going to multiply the top equation by 0.866, multiply the bottom by 0.5. This will allow us to eliminate the term in the middle, the term with the TB. So now if we add straight down 0.866 TC, the TB's add to 0, and that is equal to 111 newtons. Divide by 0.866, and you get that the tension in C, 128.18 newtons, and we already know from before that TB is going to be equal to that, and so we get the same for TB. TA, still 150 from the first part.